So we're going to take a look at substitution again, but this time, so-called substitution with fractions. And the method doesn't change. It's just some of the algebra, so the operations, are a little trickier because we have some fractions. We even have a decimal mixed in here, so this one's going to be a bit trickier to work with. If you remember from the last part, both of these are set equal to y, which is great. We don't have to do any rearranging. Sometimes that's not the case. Sometimes we have to rearrange and isolate a variable, but in this case, we have an isolated variable. We'll call this equation 1 and equation 2, and it doesn't matter which one I start with. I'll start with equation 2 this time. I have y is equal to quarter x plus 7.5. I chose the tricky one here. And what we're going to do is we're going to substitute in for y this piece here. This is the other side of the equation on equation 1. So instead of writing y, we write negative 3 over 10x minus 8. Okay? And that's equal to 1 over 4x plus 7. So here's our tricky stuff. To start off, the steps are the same. We want to get the variables all on one side by themselves and the constants on one side by themselves. So we're going to bring this one over to this side. That's the 1 quarter x. So you get negative 3 over 10x. Subtract 1 over 4x is equal to, and then our other side of the equation, we have negative 8, and we bring that over. Now, a negative 8 will become positive 8, and we still have plus 7.5 on this side. Okay? Now, I don't have to write that positive. I can just write it as 8, but I wanted to make sure we understood that we're changing the operand or the side there. So I'll move these over a little. Oh, let me. There we go. Okay. So now that we've done that, we want to collect our like terms. So on this side, it's relatively easy. 8 plus 7.5. That's actually just going to be 15.5. So we have a decimal on one side. This side gets tricky. We have to add these together. And we're adding the coefficients. But the problem here is we actually can't add these coefficients without manipulating them a little. Because this is addition of a fraction, we need the denominator to be the side. So we're going to do some side work here. I'm going to call it a side note.
Can I have another one of my ice cream?
You have to go ask Mommy.
Mommy's not here.
So we have negative 3 over 10. And I'm not going to bring... Actually, no, I'll bring it over. It's important that we know this. X. And then we have minus 1 over 4x. We need a common denominator. Something, a multiple of 10 and 4. An easy way to do it is just to multiply the two together, right? I can technically go say multiply everything over here by 4 and multiply over here by 10. We might have to do some reducing after if we take that route, okay? But it'll always work. So if you want to do that, you can do it. Technically, a lower common denominator would be the number 20, and we can get them both to 20, but we'll use this one because this one technically always works. It's just when it gets to really large numbers, it can be very, very tricky. So we're going to change our numerator. Negative 3 times 4 is negative 12, and 10 times 4 is 40x. And then on the other side, 1 times 10 is 10, and 4 times 10 is 40. Great. Common denominator. We've got it now. So I'm going to actually rewrite it back in. 12 over 40x minus 10 over 40x. Okay? We can now work with our coefficients. When we add or subtract fractions, the denominator stays the same. So their answer is going to be over 40, and the x isn't going to change. It's just the numerators. So negative 12 minus 10 is actually going to be negative 22 is equal to 15.5. Now, this is messy. I got fractions on one side. I got decimals on the other. This is a bit of a pain. I'm actually going to do some converting. I'm going to turn it into fractions, which I know most students will go, why on earth would you do that? I'd rather have decimals. Fractions, when you get used to them in algebra, they're actually much cleaner to work with once you know the rules nicely. So if you want, we could technically figure this out quickly. What would that be? 11 over 20. Maybe that's not such a nice fraction. Oh, that's probably like 0.5. 2 or something like that. But I'm going to change this side into a fraction instead. So to change this into a fraction, I can technically put it over 1, 15.5 over 1. And I know 0.5, if I ever multiply it by 2, that's actually going to give me a whole fraction. So I'm going to get a value over 2. That's actually going to be 31. Okay? If you used a calculator, you could have got to it relatively quickly too. So we get 31 over 2, and then 22 over 40. So at this point, really this becomes more of a practice in do you know your fraction rules? Because we were gone through the process, we're on the right step, we just have to isolate our x. It's just do we know our fraction rules, and which could be a bit tricky. Okay, now here, I need to get this x by itself, and this is multiplication. So this part is confusing. How do you divide by negative 22 over 40 is the question, right? That is a fraction divided by another fraction. Blah. A shortcut to this, if you can memorize this when it comes to trying to create zeros, or sorry, I should say ones, you multiply by the reciprocal. So just do this, 40 over 22, the negative value, okay? And then make sure you do that on this side, negative 40 over 22. On the right side of the equation, these two things cancel out. They create a 1, which is very nice. We end up with x. This is the tricky part here. 2 times 22 is 44, but what on earth is 31 times 40? I'll quickly tell you that it's 1,240. Okay, at this point, we should probably employ a calculator. We can work it out by hand, but really this isn't a practice in long division. Let's do this. 1,040 divide 44. What's that give us? Ooh, yeah, very nice. 28.18 roughly, okay? If you remember back to our Desmos, our x value, see if I can come back to it, was 28.182 they rounded to. The other thing we have to find is that y value, okay? So let's zoom back out again. To find the y value, we go way back to the top again, and we just have to plug in our x value for one of these. Now, I'm going to plug it into this one here. Just because it already has a decimal with it, maybe we'll work in decimals on this one. So I'll get quarter x, 7.5. We bring over equation 2. So it's pretty involved when we work with fractions. Y is equal to 1/4 x plus 7.5. Remember, the important part here is, hey, plug this in for x. That's what we need to do. So we're going to say y is equal to 1/4 times, here's our value, 28.18 plus 7.5. Okay. I can technically turn this into a decimal. So at one point we turned the fractions. This point we're turning the decimals. We're just doing this for speed of calculating now. I'm going to go ahead and use a little calculator here to help us out. And we'll speed through this process a bit. Because really, I just want to make sure you know the substitution piece. So 0.25 times 28.18 gives us 7.045. And I think I may have written this. Write that down right? I think so. Oh, I know my error here. This answer was negative 28. Which means this is a negative value. Okay, good. I thought it was a much smaller number. We just have to subtract these two pieces now. So subtract 7.5, and we get negative 0.455. We go back to our Desmos assignment. After all of that hefty work, 0.55. Oh, shouldn't be a negative value. It's a positive value, yes. And there we have a pretty tricky fraction question we've dealt with.